You want 2 minutes, 1 minute.
Yeah. Hello. Oh. Okay. Sorry. Hello, everyone. It's 2 o'clock. Just a couple of minutes past 2 o'clock. Yeah, we want to start the presentations of the projects. First, I want to remember a number of things. Right. So this is an IETF activity, a meeting. So the note well applies also for this session. You must be, I assume everybody is aware of that. So this is agenda. Where are we now? We are at 2 o'clock project presentations. At 4 o'clock the hackathon, and so we have presentations of about 3 minutes for each project. And Charles will be in front of you, giving indication of 2 minutes, 1 minute, and stop. So here at the table, just in front of the presenters. Okay, we have been there. So if you haven't done upload your presentations, please do so. We run the presentations in order that they are uploaded on the data tracker. So we have made 2 exceptions for people with timing constraints. Okay. This is the README. We have discussed that. I also want to make you aware of the Hackdome Happy Hour. That's tomorrow evening at 6:30, 7:30. It's in room G304, the 3rd floor. So there's free snacks and a cash bar for drinks. Everybody's invited. Also, please, the projects can register their projects at the wiki, and we make room for you. So everybody's invited to to be present there. It has to be shown to be a good time to share your ideas and your project with other people that didn't attend here today, or even with the people here in the room. We have seen good discussions and great interest. Thanks. So for the rest of the week, the same room, that's G304, will be the code lounge. So it's free for everybody to have discussions, to continue your development, your interop tests, etc. So it's available until the end of the week, Friday afternoon. It will be closed. Good. Again, I would like to thank the sponsors, Ericsson, Meta, and ICANN for sponsoring the hackathon event. Yes, I would like now invite the first speaker. Right over here, sure. I have to, right. Stop slide sharing and then, right. There we go. Here, I think, share this one. That's yours? Okay, yeah. Please go ahead. Thank you.
And then
oh yeah, just the arrow.
Just the arrows. Okay, thanks guys. My name is Andrew Alston from Liquid, and we're going to talk a little bit about what we're calling Trusted Domain SRv6. Now, okay, is there any way that I can see the slides on the screen as we move them or not?
No. Yeah, we can, sorry. I can, sorry. Close this one.
There we go. Now I can actually see what I'm saying. So what we wanted to do as our hackathon plan was conceptualize something called Trusted Domain SRv6 and basically create a draft 0.0, but in a collaborative manner so that it's not being drafted in a room, and use the hackathon to get a lot of feedback from it. Now, SRv6, as we see it, does not adequately realize the requirements of Section 8 being the security section of RFC 8402, which is the SRv6 architecture document. As such, SRv6 has demonstrable security flaws. And so we decided to collaboratively come together and try and write a 0.0 draft, getting feedback from people in the room while we're sitting here so that we can refine it and bring people a document into the working groups later that makes sense to everybody. And we wanted to write something that addresses the issues but maintains all the current work. What we got done, we are very close, and we're hoping to submit this next week. We got a lot of solid feedback, very useful to do this type of work in the hackathon. There's a URL for the draft there, and we said the primary conclusion is we need to give SRv6 a new ether type. And we intend to complement the existing work rather than replace it. What we learned, we confirmed that there's strong interest from the operator community. There were long discussions about where we were imposing the new ether type. We are hoping that the benefits of what we've got will encourage people to adopt it. And we found that obviously drafting collaboratively in the context of their hackathon, which is not a normal way to create a draft, was actually really, really useful because of the amount of feedback that we got. As a wrap up, the team members who were working with us, primarily myself, Anthony Somerset, Tony, Wei Ching, Tom Hill, and our contact details are all on the draft. And if anybody's got any questions, we're around. I'm here all week, as are all the team members. And I can take some questions now if there is time for them. But thanks very much.
Any questions? No? There are mics here in the room. But, okay. Thank you, Andy.
Thank you.
Okay, next one is the PQ presentation. There we go. Give me a moment to find it. There we are. Oh, sorry.
We'll be able to see them.
Sorry, it was too early to click. Share. Yeah, okay.
Okay, yes. So our project is the PQ in X509. And yeah, we have a number of goals in this project. This is actually our second hackathon. And the first one was to just to see these new PQ algorithms. How do they work in X509 structures, keys? And we've also expanded more to protocols more recently to test interoperability between the different algorithm implementations, also to gain experience with using these new algorithms, and also to provide feedback to the standards. So you can see there's a number of drafts there, and there's probably even more that we make use of, because X509, as you know, is quite a big area. Okay, and so what got done? So this is actually since 115, because we've actually been meeting monthly. So every month we have at the beginning of the month, we meet at like really early in the morning, because we're, you know, we welcome everybody from around the world that wants to join in this. We've been using the Gather platform. It's worked really well for us. Although the last meeting, we actually hit the cap of Gather. I think it's 10. So we're going to either have to look for a new platform or Gather would have to be extended. But anyway, just wanted to point out Gather has worked really well for us. In this hackathon, and since 115, we've done a lot of work in test. We have a compatibility matrix on the different applications and how they work together. And we're working to expand that to be more granular. We've also added CMP structures, so that was something new, expanding to some protocols. There's also, there's a little bit of work with CMS message starting. CMS is for using cryptographic message syntax, but we need actually more people to do some more interoperability, especially with chems, because that's a new area. We also have looked at the hybrid certificate, catalyst certificates. That's essentially putting PQ material in extensions and certificates. Also, we've looked at the composite certificates. That's another way of doing combining key materials. And also, yeah, we also had some fun with an experimental SIA extension. So that was what got done. What we've learned, I don't have a lot of time. So there's lots of discussion about libopenquantumsafe. That's basically the product library that many of us are using. What's the future of that going to look like? Obviously, we know we're going to have to pick up algorithm implementations in the future. So it was good. We have some members that are actually work on that project. So that's great to have them as well. Our project is actually goes beyond the scope of IETF as well. We've had interest from the NCCOE, for instance. For instance, our OID compatibility matrix table has been suggested to, just because people need to talk together. These aren't standardized. So that's been put forward as a way that people can interoperate with each other. There's also been a lot of interest in the hybrid certificate formats, which I mentioned earlier. A lot of our kind of sub-teams almost sub-team groups have been working on a number of different formats. Just a couple other things. Yeah, I guess what we found too is adding PQ signatures has not really been a problem. It's pretty much just worked. For instance, like in CMP, it works. In Chem, it's probably going to take a little bit longer to get that working, just because the basic structures do not yet exist in most languages. There's been a little bit of work there. A lot of us want to implement that, but it's going to take a little bit more time. And I mentioned briefly before about the SIA extension. We started looking at one of the drafts is basically putting an extension into a certificate to find alternate certificate paths. We actually found if we use an SIA extension, it can work really well. So we're going to give feedback to the authors of that draft. And so, yeah, that's pretty much it for this time. We're going to continue monthly meetings as well. The next one will probably be May 1st. And yeah, this is the team. We have quite a number of members, a couple new first-time members this time. We had a number of people remote as well this time, three to five, even though it was like 12 hours difference, right? They still came. So there's a lot of people dedicated to this project. So anyway, it's going well. So thank you.
Thank you. There we go. Right. Okay. And there we go. So again, I don't know, it's remote or local or on-site presentation, but the next one is the Alto Transparent Information Publication. Is remote maybe? I think it's remote. Yeah.
Hello. Yeah.
Please go ahead.
Yeah, this is a remote presentation. Thank you. So this is
so
our.
can you speak up a little bit?
Sure, let me try. Is it louder? Hello.
Please go ahead.
Hello. Okay. The slide is still loading. Okay. Yeah, I can see it's a page 2 right now. So thank you. So this is our project so this project try to provide the reference implementation for the Auto Transport Information Publication Service. So this is a charter item which is in the Auto Working Group. And I try to give the reference implementation in our current Open Auto framework. And we have presented this framework in the past IETF hackathon. And then we try to deploy the living demo in the National Research Platform community cluster so that everybody can access it to try the new extension for the auto protocol. And so this project tries to implement the document. So next page, thanks. And for the current implementation, the basic idea is that we will store the working history of the subscribed auto information results into a persistent database and maintain the update graph of the information chain in the Kubernetes directory. And then we'll extend the current auto protocols they did not found in the auto server to support the transfer information publication service at the front end, so that the client can subscribe, unsubscribe, and get the updates of the given auto information result. So next page. So let's give some details and the progress of our current implementation. So the update graph is very simple. So each update graph will represent the data change of each subscribed information results. So the node will retain the result state, and the 0 state will reserve for the initial empty state, and other nodes will retain some running state for the resources. And so each stage, we can see the updates from the one node to another state. And the tips will give the method summary of the update graph, or there's some metadata for the update link. Yeah, so next page. So you can also use the tips to get the incremental updates in some different formats, like the tips merge patch and the different patch. Yeah, so next page. So our current implementation is a containerized. So yeah, you can see we have the several Docker containers to provide the different features of the OpenAuto, and they have the keepers and the core of the auto servers to support this service. And so we'll run a demo in the app cluster during the tomorrow's hackathon happy hour. Yeah. Next page. Yeah, that's the current features. We have both the missing features and the source code that you can check. Yeah, next page. So we do learn some lessons from the during our custom development, and we'll report these issues to the working group to give some feedback. And yes, so next page it's about some ramp up. So this is our current team members, and yeah, you can go to the last page. Yeah. Yeah, there's the current our team members and some open issues in the GitHub you can check, and yeah, in this you can contribute. Yeah, thanks.
Thank you. Yeah, given time, there's no room for questions. Thank you for your contribution. All right, so going to the next presentation, that will be Alto AOM Young presentation. And again, remote?
Yes, it's still our team. Yeah, it's a different project.
Okay.
So yeah, this also you can go to the next page. Yeah. So this project tried to give some reference implementation for the Young driven the operation and the management. So for the auto server and the client, and also we try to put it into our OpenAuto framework, and we've also provide the set of the vendor extended auto Young modules for the current OpenAuto implementation to support some implementing specific features. So this try to verify some concepts that's defined in the auto OEM draft. Yeah, so next page. And our current progress is that we have used the Youngson to push the Young data instance to the OpenAuto configuration system. So use the Young library to manage all the Young modules. And we have defined a set of the vendor specific modules for the instance specific data sources and the algorithm for the OpenAuto server. And you can use the kind to develop the command line tools to quickly set up the OpenAuto server using the Young-based configuration. So we'll also try to run this running demo tomorrow. And yeah, next page is about some lessons we learned during the development. Yeah, can go to the page 4. Yeah, we do have some lessons we considered during our implementation. So some configurations I think is still missing in the current defined modules. So we'll try to take back to the working group to update to see how to update the current document. Yeah, to solve the issue. Yeah. Yeah, that's all.
Okay. Thank you. Any questions for the presenter? No? Okay, thank you very much for your contribution.
Thank you.
Let's see. Next up is BPF at the IETF. It's over there, the table. Okay, please go ahead.
All right, hello. So we are the BPF table. And for our hackathon, well, first let's start by talking about BPF for those of you who aren't familiar. BPF is both an instruction encoding, an ISA, and a runtime that lets you run programs in a privileged context like the operating system kernel safely. So without fear of crashing, it's very high performance, and you can do a lot of interesting stuff as we'll talk about. So there's actually an ongoing effort to standardize BPF, and one of the reasons we're here, in addition to just being able to participate in the conference, is to discuss the possibility of standardizing BPF with the IETF. So I'll talk about that a little bit more at the end. But the main purpose of the hackathon was to learn, and so we'll talk about that at the end. But in the interest of learning, these are some of the many things that BPF can do. I don't know if you can see any of that. Hopefully you can. You can plug into various parts of the networking stack. With XDP, you can plug into the networking stack before you even create a socket. It's on L2, so before you even have to create a socket buffer, you can add IPv6 headers. We actually spoke to somebody at the conference who's adding using BPF to add to add extension headers for IPv6 and doing all sorts of interesting things. So yeah, there's a lot to do. You can study this, in peace and quiet later if you're interested. So in addition to networking, BPF can also be used for scheduling, and this is a very recent addition to BPF. But you can actually implement scheduling policies for the whole system in BPF programs. And so we've been using this at Meta to experiment with changes to CFS to see how scheduling policy changes will affect our fleet. And we're also using it to actually implement schedulers that we're using in production. So it's pretty interesting. There are some folks at our table who are playing around with it and getting it set up. And if you're interested in this, you can find me and talk about it anytime over the week. Happy to tell you about it. So yeah, getting to the accomplishments. Like I said, the goal was to learn about BPF. There's a self-guided lab that a lot of people at our table took themselves through, where through the web browser, it spins up a VM and tells you how to use BPF and gives you some instructions. Some folks at the table also built a kernel, compiled the kernel, and in a VM we're running some SCED-EXT scheduling policies. We actually landed some patches in the upstream kernel that adds documentation for BPF in service of standardization. And then we also had a side meeting to meet with folks using BPF for their own purposes. So PDM, performance diagnostic metrics. Like I mentioned, they were using BPF to add extension headers to IPv6. So yeah, that's it. Mostly a learning experience. And there's a BOF tomorrow at 1 p.m. in G403. Yeah, G403. So if you're interested in the standardization effort, please come and join the discussion. And yeah, that's it.
And any questions? No? Okay. Thank you very much. Up next is the dot unilateral probing. Yeah. There you go. Can use the arrows for. Yeah.
Hello, I'm Yorgos with NLNet Labs, and together with Stefan, we worked on the unilateral probing draft. We wanted to discover if authoritative name servers speak DNS over TLS, and we wanted to check the probing by the resolver for that. We got a lot of input for the draft authors, which we will address both here in person and bring back to the mailing list. We have new unbound code, but because it's hackathon, it's not public, but it's a good base for further implementation. We did interoperability testing with unbound Power DNS recursor, Drink, and a lot of ADOT servers we found on the internet. On this link, you can find more details about what has been done. Some interesting questions. When do you decide that you can turn down your encrypted channel and fall back to plain DNS? For example, are serve fail and refused answers acceptable as DNS answers, or you need to fall back to plain DNS? Interesting questions about if you know that you have encrypted channels available, do you need to prefer them? Or do you want your resolver to be more performant and then just pick the fastest server and be done with it? This can also be an interesting configuration option and leave it to the user to decide. Another one is lazy probing. So do you want to probe for encrypted channels when you have time, or just always find the privacy channels if are available? And we also saw a lot of edit servers already deployed, and even in the root, B root, if I remember correctly. The team was me and Stefan, and if there are any questions, that's it. Thank you.
Thank you, Yorgos. Righty. Yeah, there we go. Sorry. Okay. This one. Oh, we had this one. Next presentation is the IETF Foundation. Right. Thank you. Can use the arrows for hand. Yeah. Cool.
Hi, good afternoon, everyone. Thank you. So this is our first hackathon, so it's been a bit of a learning experience. Essentially, we are building an SDN controller that's hosted within Etsy. It was code that was contributed from a European Commission funded project called TerraFlow, sort of a 3.5-year project, part of the Horizon 2020 funding framework to develop an orchestration and controller platform for sort of 5G and beyond services. So essentially, the middle box there is the TerraFlow SDN controller, or TFS for short. And our interest at the IETF is really on the northbound interfaces between the controller and sort of some higher layer orchestrator. In this case, it was OSM, open source Mano, but it could be another project, say, within the Linux Foundation. So there are several relevant RFCs. These are mainly things like L2 VPN service model, network model, L3 VPN service model, network model, and emerging work around some of the slice instantiation. So we weren't entirely sure what we were going to sort of let ourselves in for, but we know that having authors actually available to us made some of our implementation decisions a lot easier. With some of the data models, especially when the IETF are involved, they tend to be extremely comprehensive. And from an operator perspective or an implementer, it's quite difficult to know what is sort of mandatory for a specific use case, what's optional. So it's been really useful just to have conversations with people who are actually responsible for developing these standards. We also have remote participants, which has been a bit difficult because of the time aspect, but overall we've managed to make several significant advances. So we've expanded some of the implementation on our northbound interfaces for layer 2 services and slice management as well. And that's actually packet over optical services. We also, this has been an interactive process. So we've updated documentation. Even just installing the platform from scratch has kind of been a useful exercise for us with people who aren't maybe actively involved in the project itself. So I think we've made several we've had several significant outcomes. More deeper implementation of the Yang models themselves, planning for future hackathons as well with new work, and just dissemination and overall sort of marketing of the platform has been a really useful exercise. So you can see here the members involved across various stakeholders. So we've had operators, vendors, and users, and there's various links to the project itself. Thank you.
Any questions? No? Okay. Thank you and welcome to the IETF Hackathon. Yeah. Right. Up next is the BMWG presentation. Yeah. Okay. Can you stay?
Hello, everyone. So this is the BMW Container Infrastructure Benchmarking team. So in this hackathon, we use the activity in hackathon to provide a benchmarking reference to support our draft. So our draft is focused on figure out the possible factors that can affect the container network performance, and we focus on the different networking model and different resource configuration setting. So these are the networking models that we focus on and the resource configuration setting that we want to test. This is the architectures of the user space acceleration, and we have SRV acceleration, the networking models as I mentioned in previous slide. This is the eBPF acceleration based on the usage of AF SDP and the combined model between SRV and VVP. So these are the resource configuration setting that we consider: the NUMA alignment, the CPU core and memory allocation to both vSwitch and the ports, and the service function chaining. So this is our benchmarking configuration system testbed. So we use 40 gigabit NIC card, and we use EBTK version 22. So this is our benchmarking verification. So we have provide benchmarking for different networking models. So we can see with different networking models, it can affect the container network performance. Then we also can see how different CPU allocation and memory allocation to the port can also affect the performance of the container network as well. And this is the performance of the NUMA alignment when we set the NUMA allocation to the vSwitch port and the NIC card. So this verification we provide for support for our draft, and we in the next working group meeting we want to ask for the adoption of this draft at the working group draft. We welcome any question and comment to it. That's it. This is our team members in this hackathon. Thank you.
Thank you very much. Interesting. Oh, nice results. Thanks. Up next is all right. The results from the attestation and TLS team. Is this online, remote?
Yes, online.
It's
So,
online. Okay.
remote.
Of
Oh,
remote,
sorry.
sorry. Yeah, remote. Please go ahead.
So hi, this is Thomas for the TLS and attestation virtual table. The team was completely remote this time around. We were all working in the GMT time zone. Next, please. Okay, the hackathon plan. In a nutshell, we are building an end-to-end prototype around a bunch of TLS extensions that are designed to allow attestation evidence and results to be used to authenticate the TLS handshake, which in IETF terms means we are bridging RATs with TLS. We started in London with the protocol core, and in the interim, we did some work on gluing in the TPM 2.0 attester into the Parsec API. And we are now continuing outwards, gluing in the actual attester, verifier, and relying party to the TLS core. And this is basically where we leave TLS and start entering the RATs territory. Next, please. So what got done? The bulk of the work is defining the interfaces between all the RATs roles, attester, verifier, relying party, and making sure that these interfaces remain consistent and compatible with the expectations of the TLS tunnel. And to do that, we are building on a bunch of RATs documents, in particular Quorum and EER, which is an emerging attestation result format. Also, in parallel, we did some work for assembling the demo elements into a Dockerized environment so that everyone can pull together the whole demo, which is quite complex, without having to sweat too much. Next, please. Okay, so here's the pic that sums up what I just said, so we can skip over this. Yeah. Next, please. What we learned that this is quite a complex demo, and there are many moving parts to synchronize. In particular, it turns out that picking up the right crypto format that all involved libraries are going to agree upon can be a tricky task, but can be done. And of course, as always, when doing an hackathon, one fully appreciates the difference between boxology and actual implementation. But we also pleasantly discover that the RATs draft we're building upon are quite good, both in terms of stability and extensibility. So it was not at all painful to adopt them and adapt their interfaces to our use case. So it's been all, in general, a fun and useful experience, as always. And we surely want to repeat it at next IETF and hopefully be able to show the complete demo next time. Next, please. So team members, myself, Paul, Yogesh, and Yonat, some pointers to the relevant code and drafts are in the box on the right. In particular, I wanted to note that this is part of a CCC SIG attestation project called Attested TLS POC. Please see the repo link in the box. And if you're interested in attestation topics, feel free to join the CCC attestation SIG bi-weekly calls. You're very welcome. Thanks very much.
Okay, thank you. Any questions from the room? No? Okay, thank you for your presentation. Thank you very much.
Cheers.
Right, so here we go. Yes. Next presentation is the satellite routing presentation. Yep.
Good afternoon, everyone. We did a project satellite routing. This project is mainly finished by Huawei and Nanjing University. Okay. Here is our hacks plan. We simulated the satellite network based on NS3 and combined the combined the satellite network with the existing routing protocols. And finally, we evaluated the existing routing protocols in the satellite network. This is our hackathon development environment. We did it in a virtual machine on Ubuntu 20. Okay, this is about our topology configuration. We said satellite topology consists of 200 satellites, and we said the link bandwidth is 100 million bps, and 3 ground stations include Shanghai, Nanjing, and Los Angeles. Each satellite has 4 links. It connects to its neighbors. This page shows the traffic configuration about this simulation. We send UDP traffic from Nanjing to Los Angeles, and the routing protocol is OSPF and AODV. Okay, this page shows the result of our project. This page is about the path variation of these 2 protocols. The path delay will have a sharp change whenever there is an inter-satellite link interruption or ground station satellite link switching. This page shows the variation of delay jitter. It is consistent with the change of path delay. And this page shows the packet loss about these 2 protocols. Yeah, it will have some packet loss whenever there is a inter-satellite link interruption or ground station satellite link switching. Okay, this slide shows our traffic paths changes from Nanjing to Los Angeles. Okay, so finally, what we learned, we found that the existing routing protocols such as OSPF and AODV can't adapt to the satellite network and will result in frequent packet loss and large delay jitter. OSPF protocol is better than AODV in the performance of path delay jitter, but worse in packet loss, just in this case. So in the future, we will adapt more existing routing protocols to satellite network and improve the existing routing protocols to adapt to the satellite network, and also improve the simulation speed of the satellite network. Welcome anyone who is interested in satellite network, join us to improve it together. Okay, that's all. Thank you. Any comments or questions? Okay, thank you.
There you go. So, right, satellite, PQ. Next one is the TCOS project presentation. It's on-site or remote? On-site. Good. Excellent. Excellent. You can use left and right.
All right. All right, so TCOSY is an implementation of COSY. It's a RFC 905253, a standards track for encrypted and signed messages. TCOSY is a C implementation. This project has been going on for a couple of hackathons now. This time we were particularly focused on implementing the HPKE COSY draft 4 that was just published a few weeks ago. This is the integration of HPKE. It's an encryption format, public key based, into the COSY standard. So that there's been a bunch of work on that in the working group. And with draft 4, we got a draft that was really it was the first draft that was implementable. So we got to it and did a prototype implementation of this. there was actually the main driver was tcozy, but there also Ajitami also was working on a Python implementation that's part of the Python CWT project. So we were able to produce messages and exchange them. So that's a successful kind of validation of that draft and interoperation between two implementations. The work was done by Hannes Jofanig remotely, Ajitami here in Tokyo, and myself. And there's a hex dump if you want to check it, you know. Then just a couple other little comments about tcozy, kind of progress on it since the previous hackathon. So we've got we had some very crude Cozy sign implementation, and we were just starting Cozy Encrypt last hackathon. So we've made a lot of progress now. It supports Cozy sign with multiple signers and Cozy Encrypt with multiple algorithms and multiple recipients. Still, this is prototype code, and we're next thing is to try and get it to commercial or alpha quality. And then real quick, you can see we've added some new algorithm support to tcozy 2.0. So it now supports RSA, EDDSA, AES-KRAP, and HPKE. And that's it. Thank you. Any questions?
Right. So up next we have the TEEP group project. Yes, excellent. There you go. Welcome.
Hello, this is Team TEEP. How many times is it? 3 minutes? So I'm going to present this slide also tomorrow at the TEEP session. So probably I will skip what we did today and go through about the benefit of moving from JSON to CBOR and the TEEP. So initially, TEEP was using JSON, and we moved to CBOR, and it took a little bit of iteration. And how we started was adding in the draft of the comment from the JSON similar type of the description with the comment and how you read the contents of the message format. And that was the first thing I did. That was about 2011. No, not 11, 2021, somewhere summer. And also the reason of the moving to CBOR, I thought it would be easier to explain the benefit is the size of the binary is smaller. So comparing the size with JSON and with CBOR. And then writing the draft in the CBOR and also need an example to who would like to implement TEEP protocol in the CBOR must have some way to understand. So and there's a tool from Carsten in Japanese pronunciation, but probably Carsten, and it's a CDDO tools and how to automatically use the CDDO to generate the draft for the CDDO file and also do the CDDO syntax checks. And that took some time iteration. And last IETF hackathon at IETF116 was, I think that was in London. And we finally had a command in the make file. So run this, it will check all the syntax checks. And if it's correct, the draft will be ready. And mostly the TEEP protocols draft is being stable with this hackathon. So I'm very happy and looking forward attending tomorrow's session. Thank you.
Yeah, sorry.
Yeah. Thank you. Yeah, so this is our poster, a bit of what we're doing. You can see directly on our tables. And this is the plan. Our plan is to implement our draft based on the I2NSF working group. We have our goal is to basically just make sure that we can configure network security functions like a firewall or everything with an easier configurations. So on this hackathon, we want to finalize our draft, which two remaining drafts, which is the consumer-facing interface young data model and the registration interface young data model. So what we've done so far in this hackathon is we built some user-friendly interface based on the consumer-facing interface. So we implemented the part of the young data models for the registration, where we can register some IP address for a certain type of users. And also we implemented the high-level configuration for a user-friendly interface, where a user can easily, using some sort of a natural language, that we can configure network functions. And also we provide a way to translate this security policy into a lower level. And this security policy is also shown in this user-friendly interface. And the next thing is we implemented our registration interface, which in the older version, we have the netcom server in our controller. But in this case, the server is on the developer management system side. And what the benefits of this is that we can allow a query system. Basically, you can query what kind of capabilities you need in your framework. So it allows more flexibility, and it allows more simple architecture. And also we provide this information on our user-friendly sites. And what we learned so far is basically our young data models for the consumer facing is able to provide necessary high-level information. And this can be translated well enough to the low-level policy. And also the registration interface, the latest one, simplifies the architecture, and it allows the registration and query both with these new young data models. So the next step is we kind of want to implement the life cycle for dynamic policy updates, where basically there's a verification of security policy, and we can also try to analyze of network behavior so that we can some sort of automate our network security. And we have the open source project at GitHub, and also a bit of demo which is uploaded on this YouTube. You can access it by looking at our presentation slides. And yeah, this is our team and a little bit of our photo. Thank you very much.
Thank you very much. Right. That was deep. There we go. Hey. Yeah, oh, sorry. So the next presentation is from the IPMON hackathon project. Yeah. Success. Yeah. You can use the arrows. Yeah.
Here?
Yeah.
Here.
Yeah.
Okay, thank you. Hello everyone, I'm Hannah of IPMON team. IPMON team is a new team led to previous IP Wave working groups. IP Wave's problem statement has been published as an RFC this month. This is our posters for IETF meeting. We implemented this simulation based on mobility management and international throughput. Our scenario is to make accurate handovers time with a low delay. RCUs are developed along highways to give vehicles the internet connectivity. Vehicles can connect it to RCU via vehicles add-on network as a multiple vehicles to implicit structure. To train LSTM models to predict the handover timing, RSUs retrieve the moving vehicles RSS data in Omnet simulation and remove the noise from the RSSI Kalman filter. Then we label the filtering data in two categories: handover timing and no handover timing. After that, we training the RSM model to predict the handover timing well. This is a simulation. We changed the 802.11 OCB handover simulation from IP version 4 to IP version 6. IP version 4 based handover was done in IETF116 handovers in March in 2022. This time we support IP version based on handover for vehicle network. You can check the open source in the GitHub. Also, you can check the demos in through YouTube link. We changed the 802.11 OCB handle from IP version 4 to Omnet plus simulation. We learned how to transfer the IP version 4's address structure into IP version 6 address structure. We will restate our handover with IP version 6 multi-hop communication in 5G V2X communication. This portrays our team members. From here, if you want, you can check the detail of simulation. Thank you.
Thank you very much. Up next is the, let's see. Yeah, this one, the skits presentation. Is that on-site? On-site, excellent.
Right, hi everybody. So this is the skit presentation. Our hackathon plan, we're a pretty new working group. I think 115 was our first official meeting. So we don't have any like long-standing drafts or RFCs to hack on, but we did recently adopt a couple of really important documents into the group, and in particular our architecture doc. So a couple of plans for the hackathon. One was to just sit together and hack out a whole bunch of important stuff. And alongside that, we had a coding plan to actually test it out and make sure we're starting off right. There's a lot of complex stuff going on in Skit, and so the best way to check that we're actually doing things correctly and interoperably and sustainably is to actually try and thrash it out. So what was achieved? Well, we've raised lots of new issues, certainly found things we need to work on, but we've also come to some decent common understanding. Great space here to pick up the really tricky issues and get through quite a lot all at once. And some of the complex areas are getting clearer. I can't say all of them, but the organization of the work groups and where things go, some of the stuff about registration policies and how transparent and mutual those are is a really interesting question that's coming out. And also the sort of what goes where in the structures and the sort of syntax and fine detail. In the code, we got, I'm going to say 2.5 implementations of the current state of the architecture, which is pretty thin, as we said, but for what's done, we've got 2.5 implementations done there to test the practicality of what we've written so far. And that is up to interoperability at the interface layer. So we're not going for sort of deep semantic interoperability of stored data, but everything up to that point, we're really keen to make sure that that works well. And so what we had was in the middle, we've got GitHub with an open source kind of client emulator with a reference implementation. Ori from Transmute has written one implementation, and we at Archivist have written an implementation too on top of our existing platform, and got to a position where we can register claims, arrange them into feeds, get receipts, verify those receipts, all consistent with this reference client. So what that means is we've broadly demonstrated the interop claims, the practicality of what we've written. We've shown our choices of things like COSI and CBOR are pretty decent, and it works, with one observation that it's great inside implementations. Passing across application boundaries is a bit interesting with COSI. And we've got the interoperability done. So what we've learned, biggest topic for us is identity, not just of people and things, but also the objects we're talking about. There's a lot of relationship mapping, so that's going to be the next thing. But we are on a really good track. So there we go. So we are new. It is complex. So please come review, help us, and yeah, there you go.
Thank you. Sorry. Yeah, please. Thank you. Right. Skip. The PD-Man digital twin, I hope, presentation. Is that on site? Yeah, it's on site. Excellent. You can use the arrows to navigate.
Thank you. Hello, everybody. Of course, I'm not Nalini, since she can't be here. So I will try to be short. In this presentation, we want to show what we have done in this hackathon. Basically, we have two basic problems. This is a group that we are working on. As you might know, the PDM-V2 is an extension header. So the problem is both how are we on defining it and those extension header works. To make the long story short, because we have only 3 minutes, the testing on PDM-V2 headers, real testing on real internet went particularly well because thanks to the work of our group, we found some problems with the help, of course, of some people from CDN. So we found out that some problems can be fixed. So we are pretty confident that in some cases the extension header can work. Of course, mileage may vary. There was a presentation on earlier on IP IRPG. For what concerned the PDM itself, we got some advancements, and we also talked about the actual scenario where to use PDM-V2, not only about network measurements or server measurements, but also in other scenarios, particularly on the context of one thing that is particularly important to me, that is the energy grid topology. So we're trying to apply it to other scenarios rather than just poking our servers. So we think that also the digital twin communication between the twins, the real one and the digital, can benefit from PDMV2. And if you have more scenarios and more ideas, please come to talk with us. Thank you so much. Question to Nalini or to anybody of our group. Thank you. In 3 minutes.
Thank you very much. Right. Next up is the quantum hackathon. Is in the room. Yeah, there we are. Okay, please go ahead.
Hi, this will be brief. It was myself, David Elkus, and Ananda Maiti, and we worked primarily on error management for the quantum internet. Tomography is a form of link or system characterization that you might do during bootstrapping or as a background task for continual system monitoring. But the problem with it is that the constant factors are very large. It could be many hours worth of data in order to characterize a link. So we are looking at combining that with an online form of error detection that's actually used during operations of actual links for generating quantum entanglement for sharing for applications. And that's a technique known as purification. So we're looking at combining the two of those. And we think we actually made some progress on that today. Mostly David and Anand working together on that. We also are working on some network specifications, which if you saw on the IETF attendees list, we are actually writing shared specifications for a test bed here in Japan, but it may be years and years before we actually submit something to IETF on this. But in the process of working on this, Karsten helped me solve some problems we were having with the GramDAM tools, so that was worth the trip from my house an hour from here all by itself. And we are working on some documents for defining network type nodes and definitions. And you saw on the mailing list, I released a draft of our upcoming textbook on quantum communications, and we already have our first GitHub issue on that. Comments either via the Google form or as pull requests in GitHub are very welcome. And tomorrow afternoon is the Quantum Internet Research Group IRTF meeting, I think at 3:30 p.m. So see you all there.
There we go. It's the VCon presentation. That's in the room. Excellent. Yeah. You're welcome.
Great. Thank you. I represent the VCon team here, and I want to make sure I thank Meta and Mario for helping us out with our hack this time. So we're working on the JSON format for VCons as a conversation standard. If you haven't heard of it, we're still pretty new as well. It's a way of describing a human conversation in a way in which will protect the personal data which it contains, and so that you can interchange it between systems on the internet. So if you have any more questions about the VCons, we have a BOF session happening on Wednesday, and please come over and talk to us at the table. So our job here today with the hackathon was to use the VCon to provide some kinds of examples of ways of managing the personal information in it. So what we did here is we used one of our frameworks called the conserver to create a VCon out of a WAV file, to translate it, to transcribe it into a readable format, then to summarize it, and then to anonymize it before pushing it off into an external system. So, so exactly what we worked on was first the conserver chains, which is a plugin which takes processes a VCon, Chain is meant to allow vendors to easily use our technology to keep their customers' data safe. The three links that we worked on were the transcription link. We used an OpenAI Whisper thing for that, and we learned it was very slow. Then we used another way of managing the conversation. We used a summarization link that used ChatGPT to summarize it, which was very simple to do. And part of the point behind VCons is to track the automations and AI that touches the conversation. So we validated that the standard does support that, and we've got that now in our open source repo. And finally, anonymization, which is to take the conversations that it sees and to make it completely anonymous to the next person down the chain. And we also use OpenAI for that, and that did work really well. And this was a good example of what's called prompt engineering. If you're new into this world, it's a way of using what you ask the AI to do for you. So in our anonymization, we asked it, please anonymize this conversation using friendly people as if they were from Boston. And because Dan and I are from Boston, and all I can say, it was wicked cool. So we also did a little bit of polishing on the framework. And we submitted all this stuff into our GitHub repo. It's an open source project. So any more information you need, you can get it up there. Please visit us at our table. And we have a BOF happening Wednesday at 9:30. We'd love to see you there. If you're interested in customer data privacy and automations and AI, I hope that you come by and talk to us. Thank you.
And thank you for mentioning the hackathon or the Happy Hackathon demo tomorrow evening. Thanks. Okay, we're nearing the end, so it takes more and more time for me to find the latest presentations. Here we are. BGP CT presentation. Is that on location, remote? Let's see. Somebody raises his hand here or in the Meet Echo. Remote participation by, I don't see names. And I don't see a request to speak, Meet Echo. Okay. Okay, I will ask at the very end of the presentation if the remote presenter does want to present his results or his or her results. And we go to the next. All right. Next one is the P4 implementation. There we go. Yep, that's on site. Excellent. You can use the arrows to navigate.
Okay.
Yeah.
Hello. Yeah. Good afternoon. This is Wei Changchong from China Mobile, and the project MSR6TE is mainly completed by the team from Beijing University and Post and Telecommunications. And yeah, the target for this project is to implement a demo for MSR6. The basic idea of MSR6, you can find it in the link here.
Okay. Maybe I can. Oh, it disappeared. I don't know what happened. Let's.
Something.
Yeah, I don't know. Let's change view. Maybe it reappears. No, it's the Meet Echo system. No, it's not. It's not your fault. Let's see if. Okay. Okay, we're stuck. We have to ask Meet Echo to restart this, at least. Okay, thank you. I think we're back. Okay, the presentation button is still dimmed on my screen. Well, I'm talking now to Meet Echo people. Let's see if this works. Maybe it is a network problem. Yeah, maybe it's a network problem. No, it's not. Oh, sorry, it's. Okay, excuses for the delay. Yeah. We are back. Yeah. Okay, apologies. And also apologies to you. This one.
Okay.
Yeah. Okay, there you go.
Yeah.
Okay, excellent.
Okay, thank you. Thank you. So you can consider this is a part of our presentation because our topic is to introduce a new multicast solution. If we have that, maybe the multicast performance can be optimized. So let's continue. And yeah, why we need a new multicast? Here we received some strong requirements from the large-scale data center network. For those kind of application scenario, there will be numerous multicast services running, such as AI training, the high performance computing, and storage area network. So here we give an example for AI training. When you run the AI training, the parameter server will push the parameters to all GPU workers after gradient descent. So at that moment, you need a simple, stateless, and strong multicast. So we would like to have some new ideas on that. The potential solution is multicast source routing over IPv6. Oh, it doesn't work. But I just introduced the solution. That will use a basic IPv6 network to provide a efficient multicast solution. And we complete a demo for that. And now we have upload the video on the YouTube link. So maybe you can check the slides, then you can get the link. So next step, we will try to use the solution in the real network for the IDMA. And if you are interested in the topic, you can also join us at the Happy Hour on Wednesday. So it's not so good, but welcome you to our desk on Wednesday. Thank you.
Okay, sorry, again, apologies also to the presenter. I'll try to fix this. Let's see. There we are. And okay, I hope it's switched back to a large screen. Yep, excellent. So then we're coming to the SRv6 on path delay presentation. That's in the room, excellent. Okay, there you go. And navigate with the arrows.
Yep. Okay. So, hi everybody. This is the continuation of our hackathon in IETF 115. We have 3 objectives for this hackathon. The first one is to validate and visualize 2 IPFix implementation of the 2 that we are working on, IPFix SRv6 segment routing header and on-path delay telemetry. The second objective is to calculate the on-path mean delay directly in the collector, in this case PMA CCT. And the third one is to integrate the on-path delay in our network, anomaly detection algorithm. So we have 2 networks, a physical network where we have 2 traffic engineering paths, a green one and a red one. In the red one, as you can see, we have 1 link with some delay added. And the second network is a virtual network on based on VPP. We have 3 routers that are exporting SRH and on-path telemetry information. And to the visualization, on point number 1, you see that we have the 2 paths via traffic engineering. The blue one is was the green one in the previous slide with no delay, and at the line red, we switch to the red one with delay. In fact, in number 2, you see that delay per node increases significantly. And then on the right, in number 4, you see our anomaly detection. The top is the overall score for our anomaly detection, that as soon as we switch path to a higher than normal delay, increases the score. And then the 3 charts below are the three components of the anomaly detection, where the last one is taking into consideration the delay. And as you can see, the score increases when we switch to the path with more delay. So as always, the preparation and the team is essential for a good hackathon. Beer is always welcome. And we were very, very surprised and happy to find Yuta and his colleagues working on implementation of SRv6 segment router header in XTP DPDK. And thanks to the team.
Thank you. Thank you very much. That brings us almost to the end. We have at least one presentation. Right. These are the BGP MUP, Savi interop. Is on site. Yeah. So this is in data tracker, the last presentation we have. So if you have submitted your presentation, but you have not presented it, please let us know. Yeah. Okay. No, you can put off your mask. Yeah.
Okay.
Yeah.
Hello everyone, this is Satoru Matsushima. Work for a hackathon for BGP map SAFI implementation and interop. So our hackathon plan is to implement new BGP SAFI code and do the interop together. We have internet draft for map architecture and BGP extension for map SAFI. So we have many BGP implementer here: ARCAS, Cisco, FRR, ExaBGP, Furukawa, GoBGP, and also the BMP, OpenBMP. So what got done is we have running code for BGP map SAFI supported BGP implementation. Not just for production code, but also we have open source BGP software, GoBGP. Now it's working code there on the master repository in the GitHub. You can find that. And we also have ExaBGP. My colleague did the many PR to the repo, and that all of the PR be merged already. That's really proud of us. So in terms of the interop, it's always not easy task when we have many implementer. So we manage the interop scenario by matrix. So the green cell is what we have done. I really appreciate my colleague and the member for this hackathon. Thank you very much. And what we learned, yes, we already shared what already did. We learned it's network design for interrupt scenario. It's really important, obvious. And during the interrupt, we had a better understanding on the protocol spec for the coding. That's good. So this is the most good achievement in terms of the hackathon. We have many person who it's the first time to attend the hackathon, and we have it's 11 out of the 50 person there. So thank you very much. This is my presentation. Thank you very much.
Thank you very much. So we have had all presentations. I'd like to ask the remote presenter from the Juniper presentation to raise his hand or her hand in the Meet Echo. No. No. Okay. Then thank you all for your presentations and being so perfectly in time. I'd like to remember everybody that we have tomorrow evening the Hack Demo Happy Hour at 6:30. Please register. It's a good opportunity to talk more in depth about your project and with interested people. And that's it. I would like to again thank our sponsors for the hackathon, Ericsson, Meta, and ICANN. And that concludes this afternoon. Thank you very much for your contributions, your attendance, and have a good IETF week. Thank you. Okay. Yeah.